Hello, everyone. Thanks for joining this talk. It'll be a really exciting talk by Alan Brown, Business Development Manager at Nagase ChemteX. And he'll be telling us about the recent developments of conductive inks for printed electronics. Before I give him the stage, just to note that after this talk, all the other presentations will take place in the exhibition space. And at the same time, the virtual exhibition will open. So we'll give you guys, plenty of information after this talk, so you can really easily come to that space. So as usual, the presentation is 18 minutes, 20 minutes. Alan, 2 minutes before the end of your time, I will give you a heads up. And I will also remind the audience to ask your questions. Type in your questions on the right-hand side. And as you will have seen, we will ask all the questions. So Alan, without any further delay, the stage is yours. I will come back 2 minutes before the end of your presentation.
Thanks, Kasha. Hello, everybody. Alan Brown with Nagase ChemteX America Corporation. Today, I'm going to be speaking on some of the recent developments of conductive inks for printed electronics. I will discuss, who NCU is, and then we'll go into low temperature cure inks, biosensor inks, PTC inks, low cost conductive inks, and wearable inks. Nagase ChemteX America LLC was actually founded in 1983 as Engineered Material Systems, and I'm going to guess that many people watching today might be familiar with EMS and not so much familiar with NCU. The company was founded, developing industrial adhesives, microelectronic adhesives, and then conductive inks and dielectrics about 20 years ago. We are located in Delaware, Ohio, and we were acquired by the Nagase Group in 2012. The Nagase Group consists of 110 plus companies worldwide with approximately 6,940 employees. So I mentioned previously that we develop, and manufacture conductive inks for the printed electronics market. And those applications that we primarily focus on are on the left side of this picture here. Anywhere from heaters, touch panels, antennas, many sensors, whether it's a force sensor or a biosensor, glucose sensor, wearable electronics, many different substrates. And those aren't the only things that conductive inks are limited to. So as we get into some of the recent developments for the what we've been working on here at NCU, one of those materials is low temperature conductive inks. And somebody may ask, why a low temperature cure? Well, it enables a much wider variety of plastic substrates that can be used in various applications. Some of those substrates are cyclic olefin, PETG, polystyrene, PVC. These substrates require processing at lower temperatures to maintain their dimensional stability. And they're also can be more cost effective compared to a traditional substrate such as PET, allowing use in consumer electronics, medical, and food packaging. In the bottom left here, you can see that, one of our silver conductive inks, which is CI 1095, compares resistivity at 80C and 130C to a conventional ink. And you'll note that at 80C, with just a 10-minute cure, we can get 25 milliohms per square per mil, very, very similar to a conventional ink, which again just allows use on some of these substrates that previously haven't been able to be used in the marketplace. Moving on, speak a little bit about biosensors. Traditionally done on PET, but again,